Hello, ladies and gentlemen. I can proudly present to you the theory and calculation of longitudinal dielectricity. Finally, real quick though, before I start, I just want to say I do apologize for the delay. But without further ado, let's stop messing around and let's dive into it. So I'm gonna skip over the background. If you want a background of all this stuff and like what's really going on, I have 4 other lectures on my channel. I recommend watching my Nikola Tesla Faster Than Light video for a good background and history of all this. But because I'm just gonna dive right into the theory, this is just kind of from like if you're not understanding, you probably should go back. Is what I'm trying to say. But anyway, so recall that the Tesla coil system. It's not a normal circuit, okay? It's a complex waveguide, okay? And basically electricity is things occurring within certain geometries, right? So the Tesla coil system pretty much opens up this restricted electromagnetic geometry that limits us, where we can only go 3 times 10 to the 8th speed of light, where Tesla can go 4 times 10 to the 8th, he can go about 1.5 times the speed of light. And this is by utilizing these longitudinal waves right here. So this is just a little graph of it. So this is the equivalent circuit of what's going on in Parker's circuit or Tesla circuit. It's pretty much any like Tesla coil circuit. Tesla coil theory is universal. It's all really the same idea. We'll definitely dive more into this later. But for now, just note that there's 2 paths of propagation going on. There's 2 waves going on, okay? There is our transverse wave, which is our traditional electromagnetic component. This is going horizontally versus the longitudinal component going vertically. Okay, so just note that the longitudinal wave is this vertical one right here, and we're pretty much gonna, so we'll see later how we can neutralize the transverse component. So basically note that we're using the M, the K's, the M and the K's are going to be the longitudinal components. It's basically the inverse of capacitance and inductance, which are destructive units, versus the Morse and the Morse and the what's it called? Versus the elastance K and the Morse M. So that's all that's going on. Basically right here, as I was stating earlier, the transverse geometry, everything's at 90 degrees to each other. As you can see, go take an electromagnetics class, you'll see that everything's perpendicular to each other. K is the direction of the wave. The fields, the magnetic is phi, the dielectric is psi. As you can see, they are opposing the propagation direction. This is quite a hindrance because Steinmetz considered this a loss due to hysteresis. And as you can see, the longitudinal geometry is much smoother, much cleaner. Physicists like J.J. Thomson, who was an ether physicist, Lord Kelvin was another credible source. They all found that longitudinal waves propagate through the ether much smoother with a 0-degree angle. The fields are conjoined instead of being opposed, as shown previously. So recall, this is all from Eric Dollard wireless theory. So recall that this is how we're going to symbolically express the electric wave, and we're not going to do it like with our traditional quaternion, 3D vector nonsense. We're going to do this with the Versor system, which I will get more into in a second. But basically, this is the electric wave, people. So think about it like I've been saying in all my work. You can't think about electricity is not electrons flowing through a wire. It is not. That is not what's happening, okay? This is the rotating electric wave. If you know anything about how electricity is generated, you know that it's generated through a motor, through that spinning. It's that spinning with 4 archetypes, collecting the energy at certain points. That is what's causing it. So, coming out of the gate, being generated, it's rotating, and the wave will continue that rotation. And yeah, they found ways to do it to neglect the dielectric rotation. They found a way to, force everything out of each other, and that's where you get the kilowatts and the watt meter, and they stop right there, and they don't want to look at anything else. So it's a rotating wave, people, okay? So this row right here, the first symbol with the line is just indicating it is a complex versor. Row 1 is our longitudinal. I'm going to be referring to it as the L.M.D. That's longitudinal magnetodielectric. That's the official name of row 1. That's kind of the focus of this lecture, is just what is row 1 and how do we measure it? What can we do from there? So yeah, row 1 plus K, row 2. K is, of course, the direction of propagation, which is tied to the electromagnetic component. That's row 2. And now we're going to be defining the electromagnetic component. Basically, everyone knows, E equals mc squared. That's a watt second. All c squared is, that's a unit of length over a unit of time squared. And so substituting in the law of dielectric induction right here, it's I equals psi over t, E equals phi over t. It just all the phi and the psi are the lines that are generated. So basically, when electricity spawns, it's just the ether doing things, right? It's just the ether doing work. Electricity is a property of the ether. It is not a property of the conductor. So basically, the psi and the phi are the number of lines of force that form, when there's an electric current or a magnet. So we're just substituting that relation down here, and basically you're just that's how you're getting phi is equal to this. So the number of lines are equal to this guy right here. So that's length squared over time. It's time varying over that's an m over psi, and that is the law of dielectric or electromagnetic induction. So now going farther into that, basically we're going to substitute a bunch of things in, and that's how we get our rho 2 component to equal mc squared t. T is of course the just the period. It's basically how long does it take one wave to complete a cycle is what that's going to be. That's how we can scale it and keep track of the time. But basically, with all that being said, the important thing to note is this rho 2 right here is 6.6234 times 10 to the negative 34 watt-second squared. This is what they refer to light as. They think it's a spray of photons. This is not the case, okay? As we'll see later, the watt needs to be measured by as we can see later, the electricity, rho 1, needs to be measured in terms of the Parker, not the watt. And the Parker is actually a much more natural way to do it. Instead of spraying photons, this energy takes on a more natural physical form. It almost looks as if there is a miniature sun forming in your light bulb, people. So Lord Kelvin, as I mentioned earlier, brought us the law of electric induction. So that gives us our power. So that's E times I, or that's rho over t squared. That's our total versor over a unit of time. So now, in order to define the longitudinal component, basically, just like I was saying earlier, you need to note that it is, so the longitudinal component's weird because it's the spatial version of electricity. Basically, the only reason why we have time, so it's like electromagnetic is all time varying. They had to measure it somehow. Electricity is just things occurring at certain times, and you're measuring the phenomenon occurring at that time. But they couldn't do that. That was Tesla's problem. That's why all the companies stopped backing him, because there was no way to keep track of what was going on in time, because they couldn't do it in traditional, electromagnetic terms, which is their big problem. So as Eric Dollard points out, rho 1 is the spatial factor. This is the product of psi times phi. This is the total spatial electrification. These are the number of lines of force that are formed. Okay, so essentially this is the counter space electricity. Okay, this is our goal. This is what we're trying to do, people. Okay. And yeah, the big challenge here pretty much right now is my goal in this is, so yeah, we have this spatial component, right? But the big problem, the big challenge is we have it and we know it's there, but in order to effectively study it and measure it, we do need to put a time factor on it and scale this and take some readings from that perspective. So that's my goal in this lecture. We're going to go farther into that in a second. Right now we're just going to go into the backgrounds. We're going to be establishing magnetic versors. So basically a versor is a different way to represent an imaginary number. So on my next chart right here, this will make more sense. Basically, think about it as a unit circle, right? Where this 0 right here, this KM0, this is the real line. The KM1 is the imaginary line, right? Actually, other way around in this case. Sorry, so the 1 is imaginary, the 2 is real. That's how we're going to represent it in the Tesla system. Okay, so going back to that magnetic versor, you can see that our phi 1, this is the magnetic lines in the spatial dimension. The rho 1 are conjoined with our versor on the imaginary axis. This is an imaginary number right here, but we're going to represent it as a versor. We'll get more into that later. And vice versa, phi 2, electromagnetic magnetic lines are associated with the real versor. And we're doing this right here. This is defining it on the Tesla system. I'll refer more to this diagram in a second. Basically, so you recall, so there's self-induction and mutual induction, right? That's the K is self-induction and M is the mutual induction. and it's just showing where you are in the versor. So again, note that the 1 is going to be our imaginary versor. That's our self-induction. That's going to be our unit the Tesla system utilizes, versus the 0, the leakage is what this is. So 1 is energy gain, 0 is energy loss, is how I want you guys to think about that. And same sort of deal right here. Just kind of showing what, so this is pretty much what's going on. So it's just showing the transverse versus longitudinal windings is all. Again, the longitudinal component is the self-induction, which is, you know, energy gain, versus the mutual induction, which is leakage. So now same exact thing right here, except we're just doing it with the dielectric versor instead of the magnetic versor. So again, note that the imaginary spatial version of the dielectric versor, which is capacitor energy, condenser, magnetic is inductor, so it's a coil, versus the capacitor. So the dielectric part right here is the capacitor, is all pretty much. So yeah, that's minus KD1 psi 2. This minus sign just indicates that the rotation of the dielectric and magnetic versors are opposite. That's all. We'll change it positive again, just to simplify calculation, but this is just again to show, you know. So this is just farther simplifying it. You can go into it if you want to on your own. Right here is an important part though. This is showing what we're doing. So Eric Dollard has greatly simplified calculation because of all this stuff right here. Basically, this is a quadruple versor product, people, okay? You're multiplying versors by versors, so all you're doing is changing where you are on your rotation is all we're doing. And basically what we need to note here is we're going to be using this 1s1 right here. So that is a longitudinal line product is what it is. So you can see that let this line represent the Earth, right? So the middle will be Parker's transmitter, my receiver is over here on the other end of the line. This 1s1 is the longitudinal magnetic versor, okay? So this is what's indicating that it's complex, but you'll see how we do it for calculation. But it's really important to note that this is a line product right here. And basically this is just showing, again, the math, kind of what I was saying. So we have all of our components. There's AC current is a fourth order differential equation. Essentially, these right here are our solutions. So we have 2 longitudinal solutions and 2 transverse solutions. You know, both have dielectric and magnetic forms and phases. Note that their versor is indicated, as I was saying, by KD to the n power. The n is where you are on the rotation. You'll see in our Tesla wave, though, that we're going to pretty much, we don't really have to worry about any of these except this 1s1. And this is the one that's unique because this is, you know, we're allowed to sort of bypass Hertzian physics this way, you know, showing that we're in counter space. It's imaginary. This is how we do it, people. This is how you do it. And the thing about this is this versor system has been considered by many mathematicians to be a great advancement in space algebra. This greatly simplifies calculation, okay? If you want to know more about versors, I strongly recommend, this is derived from the Fortescue polyphase system, okay? Basically, this guy Fortescue figured out a way to balance, like, there's something called eddy currents, I think they're called. Someone can correct me if I'm wrong, but I believe it's eddy currents, where it's basically like a transient in a way, and it's a very common problem in you know, 3-phase transmission lines where things can get unbalanced, and the Fortescue method is how you balance it, people. So, you know, Eric Dollard did refer me to the Fortescue method. He did say that is pretty much what the versor is, and it does make a lot of sense if you're interested. So I recommend going and reading that paper if you want farther knowledge on the versor. So right here is pretty much, again, what's going on, like how the versor, like, math works, what we're doing, like what is a cross product, what's a line product, what's a scalar dot product. As you can see, we can go back right here. Like I was saying, the longitudinal magnetodielectric component is this 1s1 right here. So this is our line product. So just representing it's moving forward in the space dimension, you know, versus the cross product is rotating, which is our transverse component, which makes sense since, you know, transverse, this is the windings of the coil, versus your longitudinal component, the straight line. And basically these dot products are scalar products. They're scalar, meaning like they're space invariant. They're scalar in the space dimension, not in the time dimension. All it is a time dimension. It's the true LC oscillation. Because, you know, the LC, the capacitor and the inductor, all they do is exchange forms of energy. Those are the 2 universal forms of energy. That's the L and the C, which exchange energy, and that's all the scalar product is in this case. So anyway, we're going to substitute all that back in, so we get our full equation with everything derived. Basically, like I was saying, we have our total wave right here. So this first term is our longitudinal, our L.M.D component, versus the second term right here, which is our electromagnetic component. So again, this is phi 2 psi 2 plus 1s1. That's our versor, indicating that this term right here is imaginary, phi 1 psi 1. And then we're actually going to neglect this phi 2 right here because we'll see. We're gonna neutralize it. I'll show you later. But basically, yeah, all these are gonna these quadrature pairs, you know, they come in pairs, you know, duality. They're gonna represent different things. So what we need to worry about is I'm only gonna get into the row 1 parts. So we have phi 2 psi 2, which is this guy right here. So this is electric induction. This is electrostatic. It's the scalar version though. So again, this is our spatial, you know, our space invariant dimension versus our phi 1 psi 1, which is this guy right here. This is our longitudinal dielectric component. This is varying axially. So this is again the forward line product, and it's not transverse. So this is just again another diagram. Forward product, longitudinal, the one that we care about. Scalar is just pretty much counter space. It's just going in, you know, as you can see right here, versus our transverse windings. And this is just showing some geometry, just in case you're interested. I'm not going to go too much into it. Basically, it's showing like what a cross product is and how everything conjoins and why, you know, why phi and psi are negative versus positive versus conjunction and opposition. I encourage you to go look more into this if you're curious yourself. And right here is how we neutralize the transverse component. Basically, I've talked about this before. It's all about impedance matching. If you know anything about radio frequency and antennas and whatnot, basically we're going to set our scalar and our longitudinal impedance equal to each other. So that is, impedance is just a measurement of like, you know, what the it's essentially V over I is what it is. Z equals voltage over current. It's a measurement of, you know, potential over displacement. So that's what this is, just in its magnetic form, you know. So that's all we're doing. And you can see by the previous geometry of, you know, the tangent of this angle, you can see why this holds true. The dielectric geometry must equal the magnetic geometry, and everything will clear up, and that's how you get Z1 equals Z2. And this condition right here is what the Tesla system operates on, you know. The Parker system, the pyramids, all this stuff is neutralizing this component because it's a great hindrance on calculation, is the truth of it, you know. So we don't have to worry about any of this Einstein stuff anymore right now because of this equation, okay? All right, so now we are going to dive more into Parker system. This is just, when I say Parker system, it's pretty much any Tesla coil like geometry. They're all really the same. You know, they've got your capacitor spark gap tank circuit being fed by a neon sign that's going to a primary coil. The capacitor in primary must be in tune with the secondary and extra coil circuit and you know, terminal capacitance, and that'll create a standing wave condition which will be able to send waves wirelessly through the earth that we can harness. So basically the thing that I want us all to take away from this part of the lecture, we need to note what the spark gap is, because the spark gap is very important in the Tesla system, because Tesla needed a way to stimulate a lightning strike. You know, this is how you create the transient. This is how you create an electrostatic phenomena within the earth, you know. It's a spark gap. It literally just creates a break in the circuit. And this is sort of what Parker is doing. You can't really tell. It's a rotary spark gap, basically. There's metal electrodes, and every time, like, they're spaced out, you know, accordingly, and every time the thing spins, it'll contact two ends, basically. Once they're both going to connect, so one electrode will connect while the other one connects to the other side of the circuit, and that'll send electricity through, and then there's a brief break while it spins, and then once it gets over to the next overlap again, it'll send electricity again. That's all really, and this creates our transient, which is very unique and displays much different properties than, you know, traditional steady state theory, which is why Tesla's work is so misunderstood. They couldn't figure out what the transient was, you know. And this is where we get into the magnification theory, because basically there's a lot going on in the Tesla thing that we do not even understand. So basically there is magnetic energy, there's dielectric energy, there's there's electromagnetic force, there's electrostatic potential, you know, there's phis and psis increasing and decreasing. There's a bunch of stuff going on that we need to really note, okay? So the important thing I want us to note is the lowercase I and lowercase e is where the magic happens, really, because this is how the Tesla system operates. This is the MMF. This is the pretty much electrostatic amperage, you know, electrostatic, you know, current. We're calling it magnetomotive force, I believe is what Eric Dollard calls it. This is lowercase I and lowercase e versus, normal displacement amperage, which is, uppercase I, versus EMF, that's electromotive force. So it is very important to note the difference between uppercase E and lowercase I and uppercase I, okay? They are much different phenomena, people, okay? They are much, much different, and only theory only accounts for this electromagnetic stuff, okay? They only account for the uppercase stuff when we want to get the lowercase, and that's what we're doing right now in this lecture, okay? So just note that pretty much this dielectric impulse is going to create a negative charge and a positive charge, which is what we have our versor for. All the negative is polarity, so it means we're in phase opposition, which our versor will allow for. We're just on a negative j unit of the unit circle. We're on j cubed. So that's all it is, but the negative cycle does provide power that we are not accounting for now with our modern theory, essentially. So pretty much it's showing the same thing. So there's a magnetic discharge with the spark gap that's created, and there's a dielectric discharge as there is a dielectric charge built up and a magnetic charge built up, So there's literally, people, so these are two forms of power that are occurring in phase opposite. So these are our four solutions. Basically, there's the supply phase, which is going to be the dielectric discharge, and the magnetic discharge. These are our supply phases, and the charges are going to be the destructive phases, essentially. So yeah, again, just note that pretty much we're creating positive power and negative power that we need to account for. And that's all that this really shows. So we're going to move on. This is the Tesla graph. So this is what is occurring within the Earth. So so here's the thing. So picture this right now. So this is our supply end, right? So this is Parker's transmitter down here, and I am on the steady state end over here. I'm on the receiving end, right? So this is the Earth right here. So notice that this takes on a graph of infinity until it gets to the receiving end, right? So since our wavelength is tuned, our lambda is essentially, a wavelength of the Earth, right? So that's how we are at infinity, okay? So notice time goes backwards, but time goes back, everything's reversed because time is backwards and space is forward, right? Space is always supposed to be forward, but think about it, because he's supplying the power, but it's coming back. It's like the back feed, it's going in the opposite direction, but still supplying energy. It's really weird. It's pretty much obeying different laws of physics. You can see from this graph right here, and all the U and the N are the ether potentials, right? So just the permeability versus the dielectric permeability versus the magnetic permittivity, I believe, or maybe I got those mixed up. But all it is our ether constants is what we're looking at. So again, another way to visualize this, what's going on within the Earth. Lambda is our wavelength, dielectric magnetic constants versus our total, induction. V is going to be 1.5 times the speed of light. That is the velocity of our wave. And here we go, people. Here's what we've been all waiting for. Here's our units, right? So this is thank you to Eric Dollar. God bless you. So this is pretty much what's going on within the Tesla circuit, right? So the total electrification, recall, this is, CGS units. This is what old school stuff before everything got fucked up. So we have our total electrification equals the magnetic lines times the dielectric lines of force. That's Maxwell Coulomb. So now we got to break this down. We got our magnetostatic component. That's phi equals I times L, no lowercase I. Electromagnetic is uppercase E times T, which is our time, which is our second. That's how we're gonna measure the electromagnetic terms. And likewise, we have the electrostatic terms. So that's lowercase e times c. That's volt times farad. And then the magnetoelectric, which is electromagnetic, is uppercase I displacement times t, where t is just the period. T is just that LC that I was talking about earlier. So again, kind of just going over everything that I just said. So the important thing we need to note here, people, is lowercase I magnetostatic potential versus uppercase I displacement current. These are different. Likewise, electrostatic potential volt is different than uppercase E electromotive force, EMF. And then again, L is just the magnetic inductance, and C is just the dielectric capacitance, measured in henries traditionally and farads traditionally. And time is in seconds. So getting another look, basically all this is pretty much like I was saying. What's going on within the Earth is just a bunch of magnetic and dielectric lines of force that unite to make electricity. All that is just the unification of these two fields. Okay, and this is what's occurring within the Earth within a certain time span. And yeah, like I was saying, all I'm saying here is, again, like I've been saying, lowercase e versus uppercase I versus lowercase I. So again, I'm going to bring up our Tesla equivalent circuit again, just in case people forgot. And as I was saying, we need to think of this as a complex waveguide. It is not just wires. It's not just charges going through a wire. This is very different because we are not accounting for this longitudinal component, because the reason why this longitudinal component is there, what they couldn't figure out is this is there because we are within the Earth. We have created a standing wave condition. This will only work if you are tuned to the Earth, you know, and everything is running properly. You know, this is a quadrupolar resonating standing wave. This is a double oscillatory relationship, okay? So we're going to now define more units. These are going to be my units that I made myself to farther simplify. So recall our total electric wave component, where we're going to we're going to neutralize the rho 2. So we're going to just neglect it for now. So transverse is neutralized, let's say now, and we're only dealing with the Tesla system. So now this is it, people. This is how we go farther. This is how we're going to teleport. This is how we're going to time travel. This is how we're going to do all this stuff, you know, saucer propulsion, electrostatic propulsion. This is the realm of electrostatics. This is it right here. I guarantee you they're expanding on this at RCA. I guarantee you they have math that we don't even know about. That's crazy stuff. But anyway, so the line above the row indicates that this is a complex versor. So we have our scalar component, that's phi 2 psi 2 plus 1s1 phi 1 psi 1. Again, note 1s1 is just indicating that this is a complex versor. It's just changing where we are on our circle. And again, recall that the phi 1 psi 1, all that is the solution. That's longitudinal magnetodielectric that we previously defined with our units. And here we go. We're going to substitute everything in now as, you know, previously established. So we have now rho equals volt second times amp second. That's our scalar. Plus amp henry times volt farad. So note that this is spatial, guys. Note that there is no time in here at all. This is spatial, and this is Tesla's wave right here, the L.M.D component, right? Versus the scalar component. Now, technically, since there's no time dimension, the second term is scalar, it's time scalar, and the first term is space scalar. Okay, so we're going to simplify the first term down to square the second squared, and note that this second right here, we're gonna pretty much, it's a second, it's measured in time, but we're setting it to our scale, meaning that depending on our value, LC equals t squared pretty much, right? As I'll show later, all it is taking putting it in perspective, because it's what our coil is doing. That is what our time is based on. We don't care about any other time except our coil, and that's how we're able to get a time out of it. So now we're gonna farther define it. So we're gonna let the n, the lowercase n, that's going to be the knock. This is going to be the scalar component of that longitudinal of rho 1, and the n, that's an Olaf or Aleph. I think it's Olaf, yeah, because that's all that Microsoft Word would let me submit. I'm limited by technology, people. But that's going to represent the neck. This is going to be the longitudinal magnetodielectric component of rho 1. So the neck is space scalar, or sorry, the neck is time scalar, and the knock is space scalar. Okay. So we're going to farther define this. So again, the knock, the Olaf, equals ampere Henry times volt farad. Again, this is the magnetic. This is this is pretty much how the magnetic and the dielectric fields like interact with each other. That's all that is right there. And then again, the knock is the volt ampere second squared. So let's go into this more. They're units of energy, people, is what they are. It's akin to the joule. So the neck is very interesting because it's complex, but it performs real work. So the way calculation works, if you look at like the Fortescue method, if you look at the Steinmetz method, they're literally they're saying that it's there, and then they just neglect the term, right? So the 1s1 is there, but for calculation, it gets removed. Okay, so we're just literally indicate. So the way that it's so simple, guys, it's complex, but we just neglect the complex component. And trigonometry, geometry, the laws say we can do it, people. So we're going in, we can do it. Okay. So we're going to farther establish our wave and what's going on. So the knock right here, lowercase n, is phi 2 psi 2 times t squared. Again, t squared is just the square root of L times C. This is the true oscillation of the system. And the neck is 1s1 times phi 1 psi 1. Okay? So therefore, our total electric wave becomes phi 2 psi 2 times t squared times 1s1 phi 1 psi 1. That is the knock times the neck. And that is our longitudinal component of our electric wave. So again, note that the knock is scalar in the space dimension. It's space invariant, and the neck is scalar in the time dimension, and that's time invariant. But the neck is where the magic happens, people, because that is the unit that is supplying the energy. You know, that's where our electrification is, you know. So in order to meter this, we're going to have to add this time relation, and that is where we refer to, Eric Dollard referred me to Charles Proteus Steinmetz. So I'm not going to go too much into it. You can go read it for yourself. It's pretty much the it's in his AC current theory phenomena, like what's going on. He has a whole section on double frequency quantities. He's pretty much saying the same thing that Eric Dollard is, just in a different way. So uppercase E, uppercase I, that's going to be the magnetic and dielectric components, but he does it a little bit differently. He represents everything in the same sort of fashion. Eric Dollard does it slightly different. And he's pretty much just showing how Versor math works. Like I was saying, like if you multiply, like, so the 1 is the real component, the j is the imaginary component. If you multiply the j times the 1, you get a j. 1 times j, you get negative j. It pretty much anywhere you want to go on the cycle, you can get there by multiplying it to a j to a certain power, or a 1 to a certain power, and that'll account for your rotation. So that's the way you have to take account into the that's how you need to take into account the imaginary number, okay? It's a rotation on the unit circle. It is not it's not a number that doesn't exist. Clearly it exists. It's there. It keeps occurring in our equations. It's there, people, okay? And this is just more geometry. All right, so that brings us to our flux relations, and this will get us into the Steinmetz power relation. Basically recall that phi 1 is I1, that's, you know, electrostatic amperage times the inductance. Psi 1 is electrostatic voltage times capacitance. Phi 2 is EMF times the magnetic time constant, which is defined down here. And phi 2 is going to be your displacement current times your dielectric time constant. So everything is defined. What I want everyone to note, to take special note of, is going to be the first term in this P naught equation right here. Okay, so this is where this is how we meter it, is this equation right here. So note that the phi 1 psi 1, this is our neck is what it is, and this is over t squared, where t squared is the true oscillation of the LC component. Okay, so we're literally comparing our scalar components to each other, and that's how we get a time duration out of it. Thank you, Steinmetz and Eric Dollard, for that. Okay, but then we also have to account for the time invariant component. Or sorry, we have to account for the neck, or the knock, which is the space varying component. So that's our phi 2 psi 2 over t naught squared, where t naught is LC over z times y. All z times y is the dielectric and the magnetic impedance. So that's your potentials and your EMF and your displacement compared in a ratio is all impedances. Now, what's interesting to note that this is going to be the power factor, because J is traditionally thought of as induction factor, but the reason why we were able to switch this up and make this a real power factor, you know, it's a real component, is because of our geometry. Recall that it was the cosine of theta, which the cosine of theta represents this part right here, the first part, and the sine of theta, which is the imaginary part, represents here. So we reverse potential and kinetic energy, essentially, is what happened here by making the Einsteinian component imaginary. So yeah, we're at 100% power factor since the system neutralized that transverse component. So we're just not even going to worry about the second term right now. All the magic happens in that first term. So we're going to farther define this now. So we have the neck over t squared plus the knock over t naught squared. And then substituting our flux relations and our previously established units earlier, this right here is going to be our Parker. okay? So the Parker is the rate of power. It's the rate at which the neck and the knock perform work, and it's a complex unit of power, but it performs real work, okay? So the Steinmetz spatial relation allowed us for a clock, okay? We can now scale this and set this to what we need to see. This is very important, people. This is very good that this happened, okay? So again, note that the neck is expected to perform most of the work in this equation, since this factor down here will definitely hindrance calculation, this LC over ZY. Okay, so the previous power equation is the formula we need to properly analyze the L.M.D component neglected in modern wave theory. So it's a complex unit of power which performs real work. This is using the Versor system, okay? The mathematics can now properly represent actual physical law that modern theories overcomplicate, okay? So we need to start thinking about electrostatics in terms of the Parker and the neck and the knock. They don't show this. They neglect it because they know that this is free energy, you know? This is how you do it, is this stuff right here, okay? So now it's seen that, you know, by creating an apparatus capable of collecting all the previous values shown, that if we have everything we need for the power relation formula, you know, then that's how you do it. That's how you measure this. That's how you can emit this, okay? And Eric Dollard does have a video of him doing it. I'll link it in the description of him actually doing it, where he set up, you know, the equivalent network of the L.M.D component, you know, using the Tesla coil schematic I've shown earlier. He actually does it. But as far as actual, like, I have it built and I've demonstrated it before. I'm not ready to, like, actually put anything out there to the public quite yet. It could be better. I'm trying to work on some tweaks right now. It works, but I'm trying to patch everything up because I want to make this right. I have a lot of T's and I's. I want to, you know, I want to dot and cross before I actually put this out there. Okay? But as you can see right there, there's our Parker right there. This is a complex unit of energy which performs real work, okay? This is not a watt. It is a different thought process and must be thought of in a completely different way, okay? So demonstration of it actually happening will be coming soon. But the theory is sound. I do encourage all of you to go investigate and experiment and try to figure this stuff out yourself, because this is how you do it, people, right here, okay? So thank you to all of the people who have helped me and given me knowledge. I thank Eric Dollard. I've talked to him personally. He did give me the green light on this. He did say this is how you do it. He said I was accurate. So thank you to Eric Dollard, and thank you to Charles Proteus Steinmetz. So if you made it this far in the video, I appreciate you. I love all of you who are fans of me and watching my stuff. I do not plan on stopping anytime soon. Please stay tuned for more. Alright, peace out.